Good day, sir. My name is Shiva Sharman Alalki Paneerselvam, and my registration number is 01DKP22F2014. So I'm going to start up with the introduction of the topic. In naval architecture, one of the critical challenges in designing a ship's structure is ensuring its strength and safety under extreme sea conditions. Among these challenges, pounding or bottom slamming is a significant phenomenon that occurs when the ship's bow lifts out of the water during pitching and then forcefully strikes the sea surface. This impact creates sudden and intense loads on the forward bottom structure, which can lead to local buckling, fatigue, or even structural failure if not properly addressed. To prevent such damage, additional structural strength is provided in specific areas of the ship. These reinforcements are essential to maintain the vessel's integrity, enhance the durability, and comply with classification society requirements. So let's move on to some main structural components at the bow. So the first one would be stem. The stem is the forwardmost vertical or slightly raked structural member forming the bow's leading edge. Its function is to provide the shape of the bow, act as the main longitudinal strength members at the forward end, and also connects to the keel at the bottom and the forecastle deck at the top. So the next component would be forepeak bulkhead, also known as collision bulkhead. It's a watertight transverse bulkhead located at the bow, usually not less than 5% of the ship's length aft of the forward perpendicular. Its purpose is to limit flooding in case of bow damage, and also it provides structural integrity to the forward compartments. So the next component would be forepeak tank. Forepeak tank is the space between the collision bulkhead and the stem, often used for ballast water. The next component is shell plating at the bow. It is thicker than midship plating to withstand slamming loads and also ice impacts. The next one would be floors and girders. Floors and girders are found to provide support to the bottom plating. In the bow, floors are often solid or bracketed and closely spaced for extra strength. The next component would be deck beams and breast hooks. Deck beams provide transverse strength and support the forecastle deck, while breast hooks are triangular brackets fitted at the stem between deck beams and shear strakes to resist racking stresses. The next components would be stem bar and stem frame connection. It connects the stem to keel and bottom structure, reinforced with Gordian pieces or strong brackets. And the last component would be bulbous bow structure. Inner stiffeners and transverse webs inside the bulb provide rigidity, and the reinforced plating to absorb slamming and wave impacts. That's all from me. Thank you.
Good day, sir. My name is Abhiraj Ananaki Sankaran, and my DKP number is 01DKP22F and 2004. And our team is get the title of Describe the Structural Component at the Bow at the Stern section. And I'm going to explain about the stern section. Okay. Structural component at the stern. The first is the transom or counter stern. That is the flat or curved aft surface of the ship that called as a counter stern. After that is the stern frame. That is the strong structure holding rudder and the propeller. That what we call as a stern frame. After that is a stern tube or shaft brackets. These brackets houses propeller shaft and keep alignment. Each is the use of the shaft brackets, which keep the stern alignment and not get any water from the outside to the ship. And after that is the rudder or the rudder post. That helps to steering system connected to the stern frame. That part is connected to the stern frame to rudder and the rudder post. After that is the aft peak tank. That is the ballast tank from the trim adjustment and the propeller immersion. That is the aft peak tank. And finally is the propeller bossing. That is streamlined housing for propeller hub, reduces vibration. It used for reduce vibration from the propeller hub. That's all from me. Thank you.
Okay, good evening, sir. My name is Sridharan Durasingam. My mentis number is 01DKP22F2015. So today I am going to explain about the conclusion and the compression part. So the bow, which is the forward part, is now only mainly designed to face the waves and reduce the resistance. It deals with impact loads from the sea and ensure the ship cuts through the water efficiently. Key structure here is include the stem, bulbous bow and the collision bulkhead. The main focus at the bow is hydrodynamic efficiency and safety in case of collision. On the other hand, the stern is the aft part of the ship and play a completely different role, the opposite role. Okay, so the stern houses the propulsion and steering system, including the stern frame, rudder, stern tube and aft peak tank. Its main focus to transmit propulsion forces and safely provides maneuverability. So in short, the bow is about to facing the waves, stability and safety. The stern is about to movement, propulsion and control. So moving to the next, which is the conclusion. So both the bow and the stern are equally important. The bow ensures the ship can safely and efficiently move forward through the waves, while the stern ensures the ship can move powerfully and be steered effectively. So together they balance strength, safety and performance, making the ships truly seaworthy. Thank you, sir.